Okay, so in this video, I'm going to go over the solutions to homework number 16, where we have to find a derivative writing out a chain rule. And this is why this is happening. So we want to find the y dx. But the problem is I don't have one equation with a y and an x. So what I have to do is create a chain rule. Again, so let's understand that. I don't have an equation that's solved for y and is in terms of x. So what I'm going to try and do is write a chain rule to find that derivative. Since I'm finding dy dx, then I have to start with dy. But this y equation is in terms of v. So if I take the derivative of y with respect to v, that would be dy dv. Times, I'm going to take the derivative of v, this equation, but with respect to x. And you could see if you have a valid chain rule, is if you could think of these differentials dv dividing out, and we have dy dx equals dy dx. So all I'm going to do is take the derivative of y with respect to v, and that would be, by the power rule, negative 6v to the negative third plus 4v, and then I'm going to take the derivative of v with respect to x, which is minus 2x. We do want dy dx, so we need to swap out that v, and this is where it gets a little tedious, for that expression 1 minus x squared. And I won't have the room to do that for all of these, but that's what has to get done in the end, because we only want a derivative in terms of x, not v and x. Same thing applies to like number 2. I want the derivative dy dx, so I'm going to start with the equation that's solved for y. And that derivative with respect to u is dy du, and this one would be du dx. And I could think of those again as dividing out. The derivative of this with respect to u would be 5u to the fourth, and the derivative of u with respect to x changes to the 1/2 power, drop down the 1/2, repeat the x, and decrease it by 1. And then this is an easy one to swap out. I would just swap out the u and make it root of x to the 4th power, which would only be x squared anyway, times 1/2 x to the negative 1/2. Next up is number 3. I want dy dx, but I have to evaluate this derivative this time at t equals 1. All right, so let's see what I get there. So this is like number, guess what here, 1, that would be 2, and this would be 3. So then dy dx would be equal to the derivative of y with respect to t times, now this gets a little tricky, I need a dt up here, and I don't have that, because this would be the derivative of x with respect to t. So if I wrote this, that would not be a valid chain rule, because the dt's are not dividing out. But what I can do is not multiply it by dx dt, but divide it by dx dt. Because then when I would invert and multiply, or multiply it by the multiplicative inverse, I'd have dt dx. Then these would divide out. So my answer here, I'm running out of some room here, would be dy dt, all divided by dx dt, and dy dt is 6t minus 2, and this here would be 6t, just divided by 6t right there. And then I'm just going to replace t with 1, and 6 minus 2 is 4, and 6 times 1 is 6, and that'd be also there 2/3. The next one, I want dA dr, so I'm going to write down dA dr equals the derivative of a with respect to x times the derivative of x with respect to r. I could think of those as canceling out. So this part right here would make that a negative 2, and this part here would make that 4 pi r. Here's my answer. The next few down here are number 7, good problems. I love these because you're just importing values from a table. So here, this would be, I'm running out of room here, h prime of x equals 5. No need for a product rule. Constants just come along for the ride. And then h prime at 1 is 5 times f prime at 1 minus g prime at 1. And f prime at 1 from the table is negative 1/3. And g prime at 1 from the table is negative 8/3. Sometimes I interchange those rows. So I'm just going to continue down here. This would be negative 5/3 plus 8/3, which equals 3/3, which is 1. That wasn't bad. In part C, I'm not going to have a chance to do all these, but in part C, I'm going to do a quotient rule. So h prime is the bottom times the derivative of the top, which is f prime, minus the top times the derivative of the bottom. That's just g prime of x, because the derivative of 1, which is a constant, is 0. All over the bottom squared. So really, these are not hard. It's just a little tedious with all the writing. I'm going to be a little quick here. Well, maybe I'll just go here to make it more clear. I'm going to kick out the x and put in 1, right? And let's see what I end up down here. G at 1 plus 1 squared. All right, so g at 1 is negative 4. So negative 4 plus 1 is negative 3. Well, f prime at 1 is negative 1/3. And f at 1 is 3. And g prime at 1 is negative 4. And g at 1 is negative 4 plus 1. So these will divide out. And then negative times a negative is a positive 1. This and this multiplied is a positive 12. And that's a negative 3 squared. I think I'm getting 13/9 for that answer. In E, my derivative here is a function within a function. So, man, I'm running out of room here. So maybe I'll come up to E. I'll put E down here, I guess. So k prime of x is always the derivative of the outside. Repeat the inside and times it by the derivative of the inside. K prime at 0 is equal to g prime of f at 0 times f prime at 0. And f at 0 is 1 on my table. F at 0 is 1. So now I have g prime at 1 times f prime at 0. G prime at 1 from the table is negative 8/3. And then f prime at 0 is 5. So I'm getting here a negative 40/3. In G, k prime of x equals, just all you have to do is take the derivative of each piece and add them. That's all it is. So it's f prime of x plus g prime of x. And then k prime at 0 is f prime at 0 plus g prime at 0. And f prime at 0 is 5, and g prime at 0 is 1/3, which comes out to be 16/3. Just really quickly to talk about these derivatives right here. In D, h prime of x would be equal to f prime of g of x times g prime of x. The derivative of the outside, repeat the inside, times it by the derivative of the inside. And just one more down here in talking about its derivative, k prime of x equals the derivative of the outside, repeat the inside, and times it by the derivative of the inside. That's where things get a little dicey. The derivative of this is another function within a function. So it's the derivative of the outside, which is g prime, repeat the inside of 2x times 2. So again, this is actually a function within a function within a function. So you start with the outside, which is f prime. You repeat the inside, which is g at 2 of x. But then the derivative of this inside is g prime of 2 of x times 2. And all you have to do from there is just replace x with 1/2. This is a pretty neat problem. So this would be f prime of g of 2 times 1/2 gives me 1, if I can squeeze that in. And then 2 times 1/2 is 1, so that's going to be g prime at 1, then times 2. G at 1 from the table is -4. G at 1 from the table is -4. Something's wrong there because you have to get a value that's given in the table. So G at 1 is -4. So why don't I have a value there from the table? I don't have an x value for that. So it's f prime of g of, oh, I'm down here, it's 1/2, right? Yeah, so it's f prime of g of 2x times g prime of 2x times 2. I'm missing a value from the table here. So if x is 1/2, obviously 2 times 1/2 is 1. And oh, I see what it is. Yeah, g at 1 is -4. So I guess I really can't finish that one because f prime, I need f prime at -4. I do have g prime at 1 here. That's not a problem. That's -8/3 times 2. But I don't have, I'm not seeing anything incorrect there because 2 times 1/2 is 1, and g at 1 is -4. My problem is I don't have f prime at -4. I only have it at 0 and 1. All right, so that was a mistake there on that part. Number 8, h prime of x would actually be a product rule. It'd be the first times the derivative of the second, which is f prime of x squared times 2x, plus the second, which is f of x squared, times that derivative of x, which is 1. So that is a product rule. The first times the derivative of the second, plus the second times the derivative of the first. And h prime at 2 is 2 times f prime at 4 times 4 plus f at 4. And f prime at 4, hopefully I have that value, that's 1. And 2 times 4 is 8. And f at 4 from the table is 5. And my answer is 13. And this one here, h prime of x, start with the outside because that outside is a power function. So you got to drop it down, repeat the inside, but the derivative of the inside is f prime of 2x times 2. Again, this is a function within a function within a function. So you box the outside, circle the inside, drop down the power, repeat f of 2x, decrease that power by 1, and the derivative of the inside is another chain rule, f prime of 2x times 2. And then just replace x with 2, and it looks like this here. And f at 4 is 5. So it's 2 times 5. F prime at 4 is 1. And that looks like I'm getting an answer there of 20. Okay. And that concludes the solutions to homework number 16, where once again we have to write out a chain rule using what's known as Leibniz notation.